Hello students, today we will discuss about differential and integral calculus of Sem1. In this we have partial derivatives. What is partial derivative? Suppose we are taking z is any function in terms of x and y. Then we are taking partial differentiation of z with respect to x we are taking. Then it is denoted by dou z by dou x. Or we can take dou f by dou x, or we can take fx. In the same way, partially differentiate of z with respect to y we are taking, suppose it is denoted by dou z by dou y, or we can also take fy. In the same way, second order partial derivative, in the sense, suppose we are taking first order partial derivative, again we are doing partial differentiation of z with respect to x, then it will be like dou square z by dou x square, or else you can take as fxx or fx square. Similarly, we can do for y, that is dou square z by dou y square. Y two times partially differentiate, z is differentiating partially with respect to y two times, so it is also denoted by like this. Similarly, suppose when you are taking partial differentiation of z with respect to y, again we are taking with respect to x, it is denoted by dou square z by dou x dou y. It is also called as fxy. That means we are taking fxy, in the sense we need to take partial differentiation of z with respect to y first, then x. So we have to take from right to left. Similarly, for x with respect to y means fyx. So see here, a function in terms of x and y, suppose, then we are denoted by z equal to f of xy. That means, example, suppose you are taking z is a function in xy, means you can take in the variables of x and y, that is sin x plus y, or sin x plus sin y, or e power x square minus y square, or tan y minus cot x, anything is fine. So it is a function in terms of x and y. In this case, how to do partial derivative? Means, suppose you are taking x alone, you are taking partial differentiation of x with respect to z with respect to x, suppose, then we are taking y as constant. Y we are taking as constant. Similarly, differentiation of z with respect to y we are taking means x taken as constant. So what is the difference between normal derivatives and partial derivative? In the sense, in that normal derivative we are taking y is also a function in x, but in this case z in terms of x and y we are taking, so where x and y are independent variables, when you are taking partial differentiation of that function with respect to any independent variable and take the other independent variable taken as constant, that is nothing but partial derivative, right? Now, partial derivative of z with respect to x at any point a b, suppose we are taking, it is denoted by like this. And in terms of limits, how you can represent? In the sense, limit h tends to 0, we are changing only x, that's why we are having here a plus h. So b is constant, that means y term is constant here, that's why b take it as it is, minus f of a by h. Similarly, partial differentiation of z with respect to y at any point ab is denoted by fy of ab. Here also we are taking, here with respect to y we are doing means x term is constant and y has changed, that's why b plus k, and that is limit k tends to 0, f of a b plus k b minus f of a b by k. So this is the representation of partial differentiation in terms of limits. Now we'll see one problem for partial differentiation. So remember that the derivative formula are same for differentiation and partial differentiation. Only thing is, in the differentiation we are taking y is a function in x. Here we are taking u is a function in terms of xy are given. When you are taking with respect to y, then we take as x constant, and when you are taking with respect to x means y taken as constant. That important thing you need to remember. Let us see this problem. U is given a function which is in terms of x and y. Then we need to prove dou square u by dou x dou y equal to this we have to prove. Already we discussed previously, right? When you are taking like this second order partial derivatives, what we need to do first, starts from right to left. Right to left you have to start, means dou u by dou y we should do, that is dou u by dou y we should do, because dou square u by dou x dou y is nothing but dou by dou x of dou u by dou y. But don't take x first, y next, not like that. So we have to start from right to left, then it will be dou u by dou y. So first find out dou u by dou y. So dou by dou y of u is nothing but dou by dou y of this total function. Now what we are doing here, y with respect to y we are doing means x taken as constant. So constant into, here it has y term, that's why it is a function. So constant, take it as it is, and this is a function in terms of y. So tan inverse y form it is. What is the derivative of tan inverse y? 1 by 1 plus x square. So 1 by 1 plus, instead of x, y by x is there. So y by x whole square. But instead of y, other than y is there, again differentiate with respect to y again. That's why dou by y of y by x. So up to here it is okay. Now minus. Here with respect to y we are doing means it is a function. It is also a function. So we are taking as what? U into v. U into v means u dash v. U dash means y square derivative 2y into v as it is, plus into minus minus, again u into v dash. V dash means again derivative of tan inverse this with respect to y. So this is 1 by 1 plus, instead of x, x by y is there, so whole square, into again instead of y, x by y is there, so again differentiate partially this function with respect to y. Now we can simplify this one like x square into 1 by, here x square LCM, then x square plus y square, and with respect to y we are doing means what is the constant here? 1 by x is the constant, take it as it is. Again y derivative with respect to y is 1. So 1 into 1 by x is 1 by x here. Similarly, this term take it as it is. Here minus y square into, here also take LCM, y square as LCM, then y square plus x square. Then with respect to y we are doing means x is constant here. And what is the function here? 1 by y. What is the derivative for 1 by y? Minus 1 by y square. So here y square gets cancelled, here x gets cancelled. Take this term into numerator, then it will be x square into here x. So total x cube by this denominator minus this term as it is. Here also minus into minus plus here, and x into by y square, take it into numerator, then xy square by this one. And from these two we are taking LCM as x square plus y square. So see here, then numerator, in numerator x as common, then x square plus y square minus second term as it is, here gets cancelled, then we are getting this one. So which is nothing but what? Dou u by dou y. This is dou u by dou y. Now dou square u by dou x dou y is nothing but dou by dou x of dou u by dou y. Again we need to take this dou u by dou y with respect to x, dou by dou x of this term. So this is nothing but dou by dou x of x minus dou by dou x of this term. Again dou by dou x of x is nothing but 1, and here with respect to x we are doing means y as constant, so 2y as constant as it is, and tan inverse of this function with respect to x, so 1 by 1 plus, instead of x, x by y is there, again instead of x any other function is there, again differentiate that function with respect to x. So take LCM here, y square plus x square, and this is with respect to x we are doing means 1 by y constant and x derivative is 1. So y gets cancelled, take this into numerator, then it will be 2 into y square by this one. Again take LCM, x square plus y square, then x square plus y square into 1 minus 2y square. So it is nothing but x square minus y square by x square plus y square. So dou square u by dou x dou y value is what? X square minus y square by x square plus y square. Similarly, we will see another problem. U is given as 1 by root of x square plus y square plus z square. Then show that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square equal to 0. So here u is given. We need to show this one in the sense here in the first term dou square u by dou x square means partially differentiation of u with respect to x 2 times, means 2 times we have to take the partial differentiation for x, similarly for y, similarly for z. See students, here partially differentiation of equation 1 with respect to x means dou u by dou x, here dou by dou x of what is given you 1 by root of this value, right? Now take this into numerator, then it will be what? Here power 1 by 2, take it into numerator in the sense minus 1 by 2 here. So it is in the form like x power n. We know the formula. What is x power n formula? Derivative of x power n is n into x power n minus 1, right? So with respect to x we are doing in the sense y and z are constants, that we need to remember, and it is in the form of x power n. So n into, what is n here? Minus 1 by 2 into x means it is power n minus 1, minus 1 by 2 minus 1. Now instead of x, this total function is there. Again differentiate that term with respect to x here, and this take it as it is. Minus 1 by 2 minus 1 is minus 3 by 2. And also with respect to x we are doing means x square derivative is 2x, we know that. What about y and z? With respect to x we are doing means remaining y, z are constant. So derivative of any constant is 0. So 0 plus 0, right? Now here 2x by 2 gets cancelled, then it will be minus x into this term. So this is what dou u by dou x. Similarly again we need to take partial differentiation with respect to x, because we want dou square u by dou x square. That's why dou by dou x of this function. Again by seeing the question, with respect to x we are doing means x is a function, here is also another function. So it is a combination of two functions. Product of two functions means it is in the form u into v. So we know that d by dx of u into v is what? U dash v plus u v dash, right? So u dash, first function derivative, minus x derivative is minus 1 into v as it is, and also x as it is. This derivative again it is in the form like x power n, so n into x power n minus 1, again dou by dou x of this x function, right? Now take this as it is, minus of this, and minus into minus plus 3x by 2, here minus 5 by 2 here power, and here derivative of x square with respect to x is 2x, and these two are constants, so 0. So this is 2x. 2 gets cancel again. So dou square u by dou x square is, first term is same, and this is what? 3 into x is 3x square, this whole power 5 by 2. Similarly no need to find for y square, because already these degrees are same. X square plus y square plus z square term is given. So simply instead of x you just substitute y, then you are getting dou square u by dou y square. That is what? This first term is having 3 terms, so take this term as it is, and here also 3 terms are there, take this as it is, and here instead of x we are keeping y here. That is nothing but dou square u by dou y square. Similarly for dou square u by dou z square is, this term is same, and 3z square into this term. Now we are taking LHS, that is adding these 3 terms, then this value is this, plus second value is this, and third value is this. Now here we have 3 terms, same terms, right? So minus 3 into this function, right? Again from these 3, second, fourth, sixth terms, when you are taking then 3 as common, and this term is also common. So take this 3 into x square plus y square plus z square whole power minus 5 by 2 taken as common, then it will be x square plus y square plus z square. So writing like this. Now take this as it is, plus here it is like powers, the bases are same here. Here power minus 5 by 2, here power 1. So it is like a power m into a power n is a power m plus n. That's why we are adding the powers. Now take this term as it is, and minus 5 by 2 plus 1 is what? By 2 LCM, minus 5 plus 2 is minus 3 by 2. Then same term will come with opposite sign. So gets cancelled, answer will be 0. So this answer will be 0. So in the next video, we'll discuss some more problems on partial derivatives. Thanks for watching.